Good morning. Here's your daily tech briefing for 2026-08-12. Today we're covering Java, Docker, Kubernetes, Jenkins, Git, and Cloud, AWS/Azure/GCP, plus the Architect's Corner. Let's get into it. Let's dive into some recent developments in the world of Java. Over the past 24 hours, a couple of interesting projects have surfaced on Hacker News, showcasing the ongoing innovation and creativity within the Java community. First up, we have Tachyon, an MCP server framework designed for Java and Kotlin. For those who might not be familiar, MCP stands for Minecraft Protocol, which is essentially the communication protocol used by Minecraft clients and servers. Tachyon aims to provide a robust and efficient framework for building custom Minecraft servers using Java or Kotlin. This is particularly exciting for developers who want to create custom game modes, plugins, or even entirely new games based on the Minecraft protocol. The fact that Tachyon supports both Java and Kotlin means developers can choose the language they're most comfortable with, making it a versatile tool for the community. The Tachyon project is hosted on GitHub, where developers can explore the code, contribute to the project, or simply use it as a starting point for their own custom server projects. Although the project has just been announced and hasn't garnered much discussion yet, the potential for custom Minecraft servers is vast, and Tachyon could become a valuable resource for developers looking to push the boundaries of what's possible in the Minecraft universe. Another project that caught our attention is Ekbatan, a modern Java persistence framework that incorporates command query responsibility segregation, or CQRS, and event sourcing. For those unfamiliar with these terms, CQRS is an architectural pattern that separates the responsibilities of handling commands, which are actions that change the state of an application, from queries, which are requests for data. Event sourcing, on the other hand, is an approach to storing data as a sequence of events, rather than just the current state. This allows for greater flexibility, auditability, and scalability in application design. Ekbatan's approach to persistence aims to simplify the complexities often associated with CQRS and event sourcing, providing a more streamlined and accessible way for Java developers to implement these powerful patterns. The framework has just reached version 1, indicating it's ready for developers to start exploring and integrating into their projects. The Ekbatan project website offers detailed documentation and guides, making it easier for developers to get started and understand how to leverage the framework's capabilities. Both Tachyon and Ekbatan demonstrate the vibrant and dynamic nature of the Java ecosystem, with developers continually pushing the boundaries of what's possible and creating new tools and frameworks to simplify complex tasks. As these projects evolve, it will be interesting to see how they're adopted and utilized within the broader Java community. Whether you're a seasoned developer or just starting out, keeping an eye on innovative projects like these can provide valuable insights into the latest trends and best practices in Java development. Let's dive into some recent developments in the world of Docker. For those who may not be familiar, Docker is a containerization platform that allows developers to package, ship, and run applications in containers, which are lightweight and portable. This makes it easier to deploy and manage applications across different environments. Recently, a new tool called P0RT has been introduced, which allows developers to see every dev server, port, and Docker container in their menu bar. This can be particularly useful for developers who work with multiple projects and need to keep track of various containers and ports. The tool is available at P0RT app, and it's an interesting solution for those who want to simplify their workflow and have a quick overview of their development environment. Another tool that caught our attention is Config Ledger, a project that aims to find configuration drift across code, continuous integration, Docker, and documentation. Configuration drift occurs when the actual configuration of a system deviates from its intended or desired state, which can lead to errors, inconsistencies, and security vulnerabilities. Config Ledger is an open-source tool hosted on GitHub, and it's designed to help developers identify and manage configuration drift in their projects. The concept of configuration drift is not new, but it's a significant challenge in modern software development, especially when working with complex systems and multiple environments. By using Config Ledger, developers can ensure that their code, CI pipelines, Docker containers, and documentation are all aligned and consistent, which can help reduce errors and improve overall system reliability. It's worth noting that both P0RT and Config Ledger are relatively new projects, and they have just been introduced to the community. As such, they haven't received much feedback or attention yet, with only 3 points and no comments on Hacker News. However, they both address specific pain points in the development process, and they have the potential to make a positive impact on the way developers work with Docker and manage their configurations. In day-to-day engineering practice, tools like P0RT and Config Ledger can be valuable additions to a developer's toolkit. By providing a simple way to monitor and manage Docker containers, P0RT can help reduce the complexity of working with multiple projects and environments. Similarly, Config Ledger can help developers catch configuration errors early on, which can save time and effort in the long run. As these projects continue to evolve, it will be interesting to see how they are adopted by the community and how they contribute to the broader ecosystem of Docker and containerization. Kubernetes has been a cornerstone of container orchestration for years, and one thing that's been constant throughout its evolution is the use of YAML for writing manifests. YAML, or YAML ain't markup language, is a human-readable serialization format that's been the standard way to define Kubernetes configurations. However, YAML can be a bit of a double-edged sword. While it's flexible and gives you a lot of choices, not all of those choices are equally good for writing Kubernetes manifests. Some features can make files harder to read, while others can be easy to misuse, leading to surprising behavior. The good news is that Kubernetes doesn't actually need most of those features. It only relies on a small subset of YAML, which raises an interesting question. What if we could create a more streamlined and simplified way of writing Kubernetes manifests? This is where KYAML comes in, a concept that's been discussed in a recent Kubernetes blog post. KYAML is essentially a way to pretty print your Kubernetes YAML, making it easier to read and understand. By limiting the features used in YAML, KYAML aims to make Kubernetes configurations more consistent and predictable. But why would you want to use KYAML? For one, it can make your configurations more readable and maintainable. When you're working with complex Kubernetes setups, it's easy to get lost in a sea of YAML files. By simplifying the format, you can more easily understand what's going on and make changes as needed. Additionally, KYAML can help reduce errors and misconfigurations, which can be a major headache in production environments. In related news, Deploya, a tool for deploying applications to Kubernetes, has released version 0.7.0. Deploya allows you to define your application configurations using a simple spec file, and then generates the necessary Kubernetes manifests for you. The interesting thing about Deploya is that it doesn't require you to write Helm charts, which can be a major pain point for many developers. With Deploya, you can define your application configurations in a straightforward and easy-to-understand way, and then let the tool handle the heavy lifting of generating the necessary Kubernetes manifests. This can be a major time saver, especially for complex applications with many moving parts. By simplifying the deployment process, Deploya can help you get your applications up and running more quickly and with fewer errors. Overall, both KYAML and Deploya are aiming to make Kubernetes more accessible and easier to use, which is a welcome development for anyone working with container orchestration. Jenkins, the popular open-source automation server, has just released version 2.577. This weekly release brings several notable changes and improvements. One major feature is the standardization of experimental Jenkins pages, which should provide a more consistent user experience. Specifically, the side panel is now independently scrollable, and the build bar is sticky, making it easier to navigate and monitor builds. This change was contributed by Jan Farasik, a member of the Jenkins community. Another significant improvement is the removal of remaining detached plugin bundling from the Jenkins WAR file. This change, contributed by Timja and Copilot, should simplify the deployment and management of Jenkins plugins. By removing the bundling, the Jenkins team aims to reduce the complexity of plugin management and make it easier for users to install and update plugins. For plugin developers, there's also a notable change in this release. The Javadoc for quoted string tokenizer, quote, string, has been corrected to reflect its actual behavior. This change should help plugin developers better understand how to use this class and method, reducing potential errors and improving overall plugin quality. Overall, this release demonstrates the ongoing efforts of the Jenkins community to improve and refine the platform, making it a more reliable and efficient tool for automation and DevOps tasks. With these changes, Jenkins users can expect a more streamlined and user-friendly experience, while plugin developers can benefit from improved documentation and simplified plugin management. The role of a developer is evolving, and Git, particularly through platforms like GitHub, is at the forefront of this change. A recent post on the GitHub blog discusses how developers are transitioning from simply writing code to orchestrating the entire delivery system around it. This shift is largely driven by the increasing use of agents, which are automated tools that help manage and deploy code. As a result, developers are now responsible for not just the code itself, but also the infrastructure and processes that support it. This change is significant because it requires developers to have a broader set of skills, including knowledge of DevOps practices and tools. It also means that developers need to be more involved in the deployment and maintenance of their code, rather than just handing it off to operations teams. GitHub, with its vast repository of open-source code and collaboration tools, is well-positioned to support this shift. The company's upcoming GitHub Universe event will explore this topic further, with sessions and workshops focused on the changing role of the developer and the skills needed to succeed in this new landscape. For developers who are already using Git and GitHub, this shift may seem like a natural evolution. However, it also presents new challenges and opportunities. By taking on more responsibility for the delivery system, developers can have more control over the entire software development lifecycle, from writing code to deploying it to users. This can lead to faster feedback loops, more efficient collaboration, and higher quality software. As the role of the developer continues to evolve, it will be interesting to see how Git and platforms like GitHub adapt to support these changes. Google Cloud Platform has made some significant updates to BigQuery, its fully managed enterprise data warehouse service. BigQuery allows users to run SQL-like queries on large datasets, and it's a key part of GCP's data analytics capabilities. One of the new features that's now generally available, or GA, is query templates for data clean rooms. Data clean rooms are secure, controlled environments where multiple parties can access and analyze data without actually seeing the underlying data. This is particularly useful in industries like finance or healthcare, where sensitive data needs to be protected. Query templates allow the owners and publishers of these data clean rooms to share predefined queries with others, without exposing the actual tables and views that the queries are running against. This provides an extra layer of security and control, as it prevents unauthorized access to sensitive data. For example, a company might create a data clean room to share sales data with partners, but they might not want those partners to see the actual sales figures. With query templates, they can share queries that provide aggregated sales data without revealing the underlying numbers. Additionally, BigQuery has also updated its table-valued functions, or TVFs, to support table parameters. TVFs are reusable functions that can return tables of data, and table parameters allow you to pass in parameters to customize the output of the function. This makes it easier to write flexible, reusable queries that can be applied to different datasets. These updates should make it easier for developers and data analysts to work with BigQuery, and to build more secure and controlled data analytics workflows. Now, let's shift gears for the Architect's Corner, 5 minutes on real enterprise software architecture and system design. The engineering team behind Cairo faced a complex problem when designing a system to coordinate AI agents in a multi-agent cluster. They needed to scale their system to handle a large number of agents while maintaining efficiency and avoiding single points of failure. The traditional approach of using a central orchestrator to manage the agents would not work, as it would become a bottleneck and limit the system's ability to scale. To address this challenge, the Cairo team developed a novel approach that leverages shared state in Amazon S3 to coordinate the AI agents. By using a distributed architecture, they were able to eliminate the need for a central orchestrator and enable the agents to self-organize and make decisions autonomously. This approach allows the system to scale more efficiently, as the number of agents can increase without being limited by a central point of control. The Cairo team implemented this approach using an open-source reference implementation called CairoFlock, which deploys and observes self-organizing agent clusters on Amazon EC2. The CairoFlock implementation provides a scalable and fault-tolerant way to manage large numbers of AI agents, making it an attractive solution for applications that require autonomous decision-making and self-organization. One of the key benefits of the Cairo approach is that it enables the system to adapt to changing conditions and respond to failures in a more resilient way. By using shared state in Amazon S3, the agents can access and update information about the system's state, allowing them to make decisions based on the latest available data. This approach also enables the system to recover more quickly from failures, as the agents can continue to operate and make decisions even if some of the agents fail or become unavailable. The Cairo team solution has important implications for enterprise software architects, as it provides a scalable and fault-tolerant way to manage complex systems. By using a distributed architecture and shared state, architects can design systems that are more resilient and adaptable, and that can scale to meet the needs of large and complex applications. This approach can be applied to a wide range of use cases, from autonomous vehicles to smart cities, and can help architects to build more efficient and effective systems. It's worth noting that the Cairo approach requires careful consideration of the trade-offs involved in using a distributed architecture. For example, the use of shared state in Amazon S3 can introduce additional latency and overhead, and the system must be designed to handle conflicts and inconsistencies that may arise when multiple agents access and update the shared state. However, for applications that require autonomous decision-making and self-organization, the benefits of the Cairo approach can far outweigh the costs, and it provides a powerful tool for architects to build more scalable and resilient systems. In terms of takeaways, the Cairo approach highlights the importance of considering the scalability and fault tolerance of a system from the outset, and of using distributed architectures and shared state to enable self-organization and autonomous decision-making. It also emphasizes the need for careful consideration of the trade-offs involved in using such an approach, and the importance of designing the system to handle conflicts and inconsistencies that may arise. By applying these principles, architects can build more efficient, effective, and resilient systems that are better able to meet the needs of complex and demanding applications. The solution developed by the Cairo team demonstrates how a well-designed system can leverage the strengths of cloud-based infrastructure, such as Amazon S3 and EC2, to build scalable and fault-tolerant systems. The use of open-source reference implementations, such as CairoFlock, can also provide a valuable starting point for architects looking to build similar systems, and can help to accelerate the development process by providing a proven and tested solution that can be adapted and extended to meet the needs of specific use cases. Overall, the Cairo approach provides a powerful example of how distributed architectures and shared state can be used to build more scalable and resilient systems, and highlights the importance of careful consideration of the trade-offs involved in using such an approach. By applying the principles and techniques developed by the Cairo team, architects can build more efficient, effective, and resilient systems that are better able to meet the needs of complex and demanding applications. And that's your briefing for today. See you tomorrow morning.